Welcome Rich Martin, a safety professional with AmeriSafe, also a former firefighter, to take us through today's presentation. Rich, great seeing you, and thanks for your service as a firefighter, and thanks for being with us today to share your expertise.
All right. Thank you very much, John. I'm glad to be here. Thank you for having me. And I really do need to come in more often. I'm just going to be the fire face, right? Because that does seem like what mostly I talk about. I understand that my previous presentations on fire prevention and fire awareness have been well received, but we've also done them a couple, 3 times. So I tried to put something together a little bit different this time and look at some different aspects related to fire prevention and fire safety awareness. So to get started, just as a reminder, if you have any questions, you can contact the FCA safety line. The email address is up there. The phone number is up there. If you want to grab a quick screenshot, it's available. This slide will show up again at the end of the presentation if you have any questions or concerns that are not addressed in this presentation. All right, so let's begin. We can't have a training on fire-related issues without having a gratuitous fire video, so we're going to just show this video. So this gentleman took a dry Christmas tree and put some newspaper underneath it, lit it on fire. And this video has inspired my son and I to do this summer, just for fun. But simple Christmas tree, real Christmas tree, not a plastic one. Little bit of fire underneath, and you can see how quickly the fire just ignites and spreads. And this video serves no other purpose than to get us into the fire mood, but also to consider your Christmas tree in the house, right? If you have a Christmas tree, make sure you keep it well watered so that it doesn't dry out prematurely. When you purchase a Christmas tree, make sure you give it a good shake or two, and if a lot of needles fall off of it when you're buying it, then perhaps it's already starting to dry out. So keep those things in mind. Never leave Christmas lights on your Christmas tree when the house is empty. Don't light up your Christmas tree for your neighbors to see, and then go out to dinner. If there is an issue with the electrical cords or with the lighting, could light your tree on fire. And when you come home, you have some remodeling to do. So, all right. NFPA, National Fire Prevention Association, is the standards group that defines what the standards requirements are for fire prevention concerns. The purpose of the code is to minimize danger to life from the effects of fire, as it says up there. Deals with evacuation plans, methods of notification, building design, how buildings are going to be constructed, what kind of exits, how many exits, where should stairwells be placed. And OSHA incorporates NFPA 101 into their standards by statement of incorporation. So when OSHA looks at a place, is it adequately protected against fire? They will refer to NFPA Life Safety Code 101 and can cite you based on the standards code, which is not a law and regulation, but apply it to the OSHA law and regulation through the general duty clause. So that's why we're talking about this line of approach when we consider fire prevention. So originally, the Life Safety Code, way back in the, I think even the late 1800s, was established to discuss the construction of stairways, fire escapes. Back in the old days, it was very common to see steel fire escapes on the outside of buildings, right? And how would you escape your unit if your apartment building or if your school caught on fire? And you'll see it in the older black and white movies where people may bail out of their bedroom window and go onto the fire escape and get down to the street. Because usually there was only one stairwell up to that floor, and if that stairwell was blocked, you were stuck. So there were a number of key incidents that happened in the middle 1900s and going forward that redefined the scope of the Life Safety Code. The Coconut Grove fire in Boston, Massachusetts was a big one. It was a basement nightclub. There was an accidental ignition of some of the decor, the wall hangings, the furniture, even the wallpaper on the walls, that ignited, and the fire spread very, very quickly in a basement. People had difficulty getting out. All right. The exit doors were constructed in such a way that you had to pull them open to leave the building rather than push out. A bunch of people got jammed up against the exit doors, and they suffocated due to the bad gases of combustion, the heat, the smoke, and of course, fire, direct exposure to the fire as well. So the big thing that came out of this incident is the code, or the standard rather, defined the necessity of having exit doors that opened outwards. So when you go into a place of assembly, a restaurant, a theater, a school building, a government building, and you want to exit the building, usually you exit by pushing that door open as opposed to pulling it back towards you and then stepping out. In 1946, there was the Winecoff Hotel fire in Atlanta, Georgia, 15-story hotel, a single stairway accessing all 15 stories. The interior finishings, wooden paneling, wallpaper, carpet, all flammable, and caught fire, spread very rapidly, blocked the stairwell. People couldn't get out, and many of them jumped to their deaths trying to escape the fire by bailing out of windows. 119 people were killed in this. As a result of this single incident, there were probably others involved, but this was the big one where they said, okay, enough's enough. Somebody ought to write a law, right? So they came up with the requirement for not only exit doors that open outwards, but multiple avenues of escape. If one stairwell is blocked, there may be another one or two that you can use instead. Unfortunately, with older buildings, how do you reconstruct a building to add these extra exits? But going forward from 1946, all new buildings needed to have multiple exits. 1958, the Our Lady of the Angels fire happened here in the Chicago area. 2-story structure. Some of the floors, the floors had ceilings that were 12 to 15 feet high. And it was a 2-story structure with a fire that started in the basement. Most of the students were up on the 2nd floor. They didn't even know that there was a fire in the building until the escape routes were inaccessible. They couldn't get out. Many of them were jumping from those tall 2nd-story windows, but a lot of them, 87 children and 3 nuns, died because of smoke inhalation, heat exposure, and other effects of fire. As a result of this incident, sprinkler systems are now mandated in schools. And stairwells, there have to be multiple stairwells. They also have to be big enough and wide enough to handle the expected load of people trying to get out in an emergency. And then fire alarm systems were also mandated. Nobody knew there was a fire in the building. Well, if there was an automatic sprinkler system that would set off a fire alarm, everyone in the building would be notified, hey, we have a fire, hopefully before the stairwells become impassable. 2003, so this is recent. Now we're looking at, hey, I think I remember this. Now, I don't know if any of you are from the Chicago area, but this was a big one. E2 nightclub stampede. You've got a bunch of people in a nightclub, and the nightclub owners chained the doors shut because too many people were coming in the front door and then sneaking over to the side and rear doors and opening it to let their friends in without paying the cover charge or the entry fee. So they chained the door shut. At some point that night, somebody let off some pepper spray or some mace, and a panic ensued, and everybody is diving down the 2nd floor stairs to get out of the building, and they get up against these doors, which are properly constructed to allow people to exit the building in the event of an emergency, but the doors were chained shut. 21 people died, and a lot of them were injured. The people that died died because of the crush of just people up against them. They couldn't breathe. They fell down, and people were trampling all over them. And was not a good scene. The owner of that structure, that facility, ended up facing criminal charges as a result because of his direct actions that defeated the safety measures that were put in place in that building through those avenues of escape. So when we look at the building that we're in, and we work inside buildings, right? We're plastering, we're painting, it's a structure, and we need to have a way to get out. The building should have an emergency evacuation plan. Generally, they're posted in the common areas on each floor for a building that's in occupancy. It's actually being used. A building under construction, though, may have nothing. And depending on the level of rehab of a rehab building, not only might there not be a plan, but exit doors that used to be exit doors are no longer, or now there's new exits that are being put in place. But a simple evacuation plan, this here is just an example of one. You have the structure, you have paths to exit, you have some directions on the left side there. Who do you call? Well, you call 911. What do? We exit to the emergency exits. Don't forget, don't use the elevators. But having a simple evacuation plan can be very effective in giving people, especially in that panic mode, some direction on how to get out of the building. Foremen and supervisors should always make sure that there is an evacuation plan available for the place in which you're working and that it is reviewed with your workers. If you have to conduct your own impromptu, hey guys, let's just, the first day on the floor here, we're going to evaluate our hazards and our control measures here. Do an evacuation and say, guys, if we have to leave this floor, here's how we're going to do it. We're going to go down these stairs. We're going to get out to the first floor. We're going to go outside and we're going to stage right over here in this location. And everybody comes here and reports, and then we'll wait for an all clear. So a simple evacuation plan, even if it's not your building, they are still your personnel, and you should look out for them in these regards. So here's your evacuation plan. We need a method of notification. Sometimes you'll have a built-in system like a fire alarm system. Sometimes it's a simple compressed air horn like that. 3 blasts on the air horn lets people know, hey, we have an emergency here. Could be medical, could be hazardous chemical release, could be a fire alarm or a fire, whatever. We're just trying to get people's attention. They look up and figure out what the problem is. Every location should have a poster showing who to call in the event of an emergency. In this case, this comes out of our safety and health manual template available through the FCA. But just a simple emergency contact poster, where the job is, who you're going to call if there's a fire or ambulance or police. Down at the bottom in that chart there, you can put in your first aid responders that are assigned to the location. And maybe the only way to get a hold of them is through cell phone. Well, their number is there, and you can call them up and say, hey, we have somebody who's got a bad cut up on the 3rd floor. Can you come up and check us out? And there you go. Response actions. If you don't have a plan, what do they say? If you fail to plan, you plan to fail. Nobody is ever going to rise to the level of the occasion. They're usually going to fall back on their training and planning. And if you haven't planned, unless you're really sharp and you've got a good head on your shoulders, most people will just end up running around like a chicken with their heads cut off. And also what ends up happening is you've got 10 people all running around telling the other 9 what to do. And nobody knows what's going on. So response action should address critical operations. Is there a piece of machinery that you really should shut down before you exit the building? All right, that would be good to know. Let's shut down the welders. Let's shut down the air compressors, torpedo heaters, whatever it is you're using. Make sure those get shut down. Exits and paths to exit should be clearly marked. If it is not an exit, don't label it an exit. And if it is an exit, make sure it's labeled so that when people have to leave the building in a hurry, there's a bright sign letting them know where to go. If the building does not have natural lighting during hours of operation, then those signs should also be lit, preferably with lights that work even in event of a power outage. So the power goes out and a backup battery kicks on and either illuminates the sign internally, or a small spotlight, an emergency light is pointed at it to show you where it is. And the emergency light will also show a clear path to the exit so you don't trip over things on your way out. When you get out, where do you go? What we see here is a picture of a structure on which a crew is working, and we have designated that northeast corner over there as the muster location or the place of assembly. When everyone gets out of the building, we go over by the red star and we wait there together until we find out that it's okay to go back into the building. The point of this exercise is we want to make sure everyone gets out, right? So once everybody assembles and you can count heads and say, my crew is out here, they're all accounted for, they're all well and healthy, then you can always send them, all right, if you want, go wait in your truck, go wait in your car, and we'll call you when it's okay to go back in. But it would be best if everybody just stayed together. Where do you put these things? This is just an example of a safety board at a job site. You can see on the board you have warning signs such as who to call in the event of an emergency, safety sign, all injuries must be reported. You have a first aid kit, you have an eye wash station. In the second board, you see SDS sheets, there's a fire extinguisher available. This is key because this is a central location. Once people have been oriented to where it is, when they need a fire extinguisher, no matter how much the other fire extinguishers are being moved because they're being used for door chocks or whatever, we know we're going to find a fire extinguisher over here. We know we're going to find a first aid kit over here. Often these are provided by the general contractor, which is great. If the general contractor does not provide something like this, you can have your own system such as this. One of my clients has been using this, I think they call it the safety cage. It's Tool Cage is the brand, but they have a safety cage. And you can see right there in the front, fire extinguisher, first aid kit, and eye wash is immediately available. Notice that it's not locked inside the box. There are plenty of times when the emergency equipment gets locked inside the box, and when someone needs it, we also have to find someone with a key because we're too concerned about opportunists borrowing our tools and equipment and not putting them back. The picture on the right, one of my clients uses this box here, and in there they keep their fall protection harnesses so that they're stored and they're protected from harm. They have their safety and health manual, their policies and procedures, obviously your eye wash station, first aid kit, fire extinguisher, and any other safety related things they might need while they're in that job site. Notice also the bright neck calls it safety green, but it makes it very identifiable. Instead of saying which orange box should I be looking in for this stuff, no, right here we've got a bright green box and everything safety related is in here. So it's a pretty good idea. Got our assembly muster location, as I already mentioned briefly. Consider weather when you're choosing your muster location. Middle of January, it's 10 below with the wind chill, and we're telling everybody to go outside and stand out there in that wind chill. Did they bring their coats? Did they bring, some way of keeping from getting hypothermia? In the summer, are they being exposed to hot temperatures because there's no shady areas? So watch out for that. Storm activity, we don't necessarily want to pull people out of a building and then stick them out in the middle of a thunderstorm. So take a look and say, yeah, if we have a problem, we're going to go to the Denny's across the street and we're just going to hang out there until the fire department is done. But consider that in your planning. Consider the activity too. If we tell everybody to go up here to the northeast corner of this parking lot, is there construction activity in that area? Is that where the fire trucks are going to end up wanting to park? Is there traffic in that area? We don't want to take our people out of the building and then put them into an area where they're exposed to other hazards. So give those things some thought when you choose your locations in which you're going to send your people. What about the capacity? You have 20 guys, but the place you chose really can only fit 5. We have a problem, right? And what about everybody else in the building? Are they going to come to your location as well? So just one more thing to think about. Hazardous materials incidents. Hazardous materials can be solid, liquid, or gas, right? Liquid tends to flow downhill. Do we want to be in a downhill location where a hazardous liquid chemical is going to flow towards us? Same thing with a gas, propane, acetylene, ammonia. The gases are being released and then they go downwind because they're blown by the wind. So we always want to choose a location that's going to be uphill or upwind of the incident. You might have to shelter in place with a hazardous materials incident because going outside may require you to go through an area that's been affected, or it might require you, might end up exposing you to the chemicals outside. Distance too, I put that in there. If you have a fire in a building and it's near propane cylinders, right, we want to be pretty far away from those. When propane cylinders go off, they can explode and cause significant damage over a great area. And for an interesting read, just Google search the Kingman, Arizona propane levee incident that happened back in the 80s, I think it is, where half a town was erased by propane cars on a railroad exploding. What else? Propane thinners, paints, all right? Thinners, they have those vapors in there that can make you loopy. Paints, of course, have the thinner in there as well, so you want to make sure you are well ventilated. You don't want to get those materials on your skin for any longer than necessary. So we wear the protective clothing and the protective gloves. And, you know, so we're stepping outside fire a little bit, but here we are talking about emergency action plan. Let's say the activities that you're engaged in are not particularly hazardous. We're doing taping, we're cleaning up, we're, you know, minor punch list stuff. But 25 feet away, another crew is doing something else that's dangerous. So we need to be attentive on what's going on in our area as well. And if we see them doing something unsafe, or maybe they're not prepared for what they're doing, hot work, for example, and there's no fire extinguisher immediately accessible, cover them and say, hey guys, don't forget your fire extinguisher. Oh yeah, thanks, forgot that. So you've made it out of the building. We're in our muster area. We counted all our heads, right? And we made sure that everyone's there. And you say, where is so-and-so? Did he get trapped upstairs? Did he not hear the alarm? Remember, you had those little compressed air horns? We need to test those. Can they be heard in every area of the building? Somebody might not have known there was a hazard, and now they're trapped in the building. Or maybe they're just in the porta-john, but it would be nice to know that all of your personnel are out of the building. Once you're out, don't go back in until the general contractor, the emergency responders, or a responsible person confirms that the emergency is over and we can go back in. While you're out there, follow the directions of the emergency responders. If they tell you to relocate, relocate. There's a reason they're doing that. They're not just being pushy. They may be moving you uphill or upwind because they're concerned about wind direction. They may be planning on bringing equipment in and they want to put it right where you are. So just cooperate with them and things will be back to normal soon. Afterwards, evaluate and adjust. Look at your response and how your workers acted during the emergency. Did it take more than 60 seconds for people to assemble at the assembly area? That might be a problem. We might need to train people. We might need to walk through a couple of drills to make sure people know what their actions are, what their expected actions are, and whether or not they even have the ability to comply with them. We had a plan to exit down this hallway and down this stairway, except today we couldn't do it because of something that changed, right? They built a wall across our exit. Whatever it is, evaluate and adjust because we want to be ready for the next emergency to do it better. Alarm systems, remember the alarm system, the purpose is to minimize danger to life from the effects of fire. In the previous presentation I did, we showed how quickly fire can spread just in a room fire that started in a wastebasket. Here we saw how quickly that tree lit up on fire. Typical rule is that fire doubles in size every minute. And the alarm will alert people to the fact that there is an emergency and allow them to start making their way out of the building before that fire gets out of control. So as we alluded to earlier, there's different methods of notifying people of the emergency. You got your strobes and your horns for a automatic system that's already in the building. They're designed to activate early to allow time for egress, but what happens? They go off and people say, false alarm. Nobody kept that smoke detector, and the finishers were sanding, and sand set off the smoke detector. And this is just another false alarm. I'm going to keep working. And as a fireman, we used to see this all the time. We'd have a building with a fire alarm, 5-story building. We would have to walk the building to make sure, find out where the problem was and make sure everyone was out. And half the building was still in there working away at their computers, at their desks, because just another false alarm, right? So never assume it's a false alarm. Test your method of notification. Make sure it can be heard in all areas of the structure above all ambient noise. The machines that are running, the baffles that end up being constructed in the building, make sure you can hear it. Assist others out of the building as much as you can, but don't go back in the building once you're out. It's not a bad idea to run the building or walk the floor and make sure everybody's out. Some people may stay because they're not taking it seriously, but many people stay because they didn't hear or they didn't recognize the alarm. All right, what else do we have? So we talked about this in the last presentation, right? Fuel has three main components. Fire has three main components. You've got your fuel, you've got your oxygen, you've got the heat, and combined together, you can get your fire. All right, if we take away any one of these three things, all right, the fire goes out. All right, but all three together, we have that fire. So fuel, we have three different types of fires typically, and they have two different types of fuel. Type A fuel is your ordinary combustibles, your wood, your paper, your plastics. Type B fires are flammable liquids, your gasoline, your kerosene, your white gas, your diesel fuel. Oxygen, generally you will have 21% oxygen in the air. If you have less, you may have a breathing problem as well because there's not enough oxygen for you to breathe. If you have more, it's usually because you brought it in with you. And then, of course, heat, your heat source, your ignition source, generally from processes, welding, running electrical equipment, heating coils, even heat of decomposition due to the improper disposal of oily rags. Oily rags could be oily, thick and viscous. They could be contaminated with thin, very volatile products such as thinners, xylene, other very thin, what's that stuff you use on your fingernails to get the fingernail polish off? Acetone, right? If you pour acetone on the ground, the acetone will evaporate almost immediately. 5 minutes later, that puddle of acetone will be gone. So that means it's very volatile. It wants to convert to a gas, and gas is what burns. Diesel fuel is not very volatile. If you pour some diesel fuel on the ground, it'll probably still be there, some residue there a week later. So the more volatile it is, the more flammable it is. But those contaminated cloths and rags, they need to be disposed of properly. Fire-resistive metal containers with self-closing lids during the day, take them outside, so put them in a bucket of water overnight so that they can't burn. Let them hang so that they dry and the volatile products off gas. Gasoline is volatile. Remember, diesel not so much, oil not so much. But we want to get those oily rags out of the building and into an area where if they do spontaneously combust, nothing's going to burn but the garbage can. Back to the NFPA 101 Life Safety Code. Again, purpose, minimize danger to life from the effects of fire. We've talked about fire alarm systems and evacuation plans. And let's talk about fire protection equipment a little bit. We also looked at evacuation routes, and we're going to look at some of those other things, but not in a whole lot of detail. All right, 5 types of fire. Class A, B, and C are the most common. Class D is flammable metals fires. Think aluminum powder, magnesium. very flammable. Sodium, extremely flammable. Sodium will burst into flame in contact with water and I think sometimes even air, depending on the humidity content in the air. And then Class K fires are fires in cooking systems. I've graded those out because the likelihood of you guys running into those is like just above 0, right? So we're not going to worry about that. But Class A, B, C, D, K, what type of fire extinguisher do you need? We're going to look at that because that's pretty much going to be your fire protection, fire extinguishment, fire prevention system. These are the typical fire extinguishers that are available. All right, we have foam. Think of pressurized water can with dish soap in it, also known as light water in firefighting circles. Wet chemical is a specialty fire extinguisher. Plain water, everybody knows water puts fire out. Notice that the arrows keep pointing to little indicators that say not safe for use, right? Do not use for this. Do not use for this. There's your dry powder fire extinguisher, the one you should be using. And then commonly we'll see these, the carbon dioxide fire extinguisher, but notice also that it also has a do not use box in there. This one does not, right? So that's a clue that this is probably the fire extinguisher we want. So if we look at these fire extinguishers here, here's a foam fire extinguisher, and it says on here, do not use on electrical fires, do not use on flammable metal fires. The reason is it's basically liquid, it's water, with layman's terms, a form of dish soap in there. The dish soap takes the water and allows it to penetrate the fuel better. Also, it can be used on flammable liquids fires because it'll spread a film of soap over the fuel that wants to off gas, and it'll prevent that gas from coming out. And when you see aircraft firefighting, when they douse an airplane and they cover it with white foam, that's what they're doing. They're just covering it with soapy suds to allow the that film to be formed over the flammable liquid and to soak into the fuel. But don't use on electrical fires because it's water, and don't use on flammable metal fires. Flammable metal fires burn so hot that they actually take your water, H2O, right, hydrogen and oxygen, and they will break down the water into hydrogen and oxygen and add hydrogen to the fire and add oxygen to the fire, making it burn even hotter. So that's why we don't want to use water on a flammable metals fire. Wet chemical, notice it says don't use it on electrical fires. These are good for cooking oil and cooking fats fires, right? They're effective on ordinary combustibles because it is also water-based, and we use water to put fires out. But don't use these on electrical, don't use them on flammable liquids. There's your water. If you put water on a flammable liquids fire, the flammable liquid is lighter than water. It will float on top of the water, and then the water, as it runs off, will carry that burning fuel away with it, which is why you don't put water, you don't grab your sink sprayer from your kitchen sink and start spraying down the burning frying pan on the stove, because you can cause a splatter effect of that burning oil to start burning other things in the kitchen, and you won't put the fire out. CO2, the key to the CO2 fire extinguisher is this bell-shaped nozzle. If you see one of those, you don't have the right fire extinguisher on this job. Note that it says do not use on wood, paper, ordinary combustibles. Also, don't use it in confined spaces. This fire extinguisher extinguishes fire by pushing oxygen away and out from the burning area. If you're in there, that's less oxygen for you to breathe. And because ordinary combustibles tend to smolder, the moment oxygen rushes back into that burning area, the fire reignites. So carbon dioxide fire extinguishers are pretty much just for flammable liquids fires or enclosed spaces that you're not going to enter. Think of like an electrical room. We don't want to throw water in an electrical room, right? But if we throw a whole bunch of carbon dioxide into that electrical room, we'll starve it from oxygen without damaging the electrical equipment and without creating electrical arc with the water. And there's the one we want, the powder fire extinguisher. Note it says safe for use on wood, paper, fabric fires, on flammable liquids fires, on gas fires, and on electrical fires. If you spray this on something electric that's running and on fire, you won't get an arc back at you. This will just start putting the burning material out. So the next question we have to ask is, how big of a fire extinguisher do we need? And we see big ones and medium-sized ones and little ones, and very often that's what I see, the little one, especially on workers' trucks, because that's the extinguisher that is required on a commercial truck. Minimum 1A, 10B fire extinguisher, the one that comes with the truck, probably. Often that is all I see on the job site. And when guys go out to buy fire extinguishers, they say, I need a fire extinguisher, and they find the cheap one. All right. Look on your fire extinguisher. There's a label. On that label, it will tell you what the rating is. A good powder fire extinguisher is going to be rated for class A, B, and C fires. And here we see this one rated 1A, 10B, C. And we covered this in the last presentation. What does this mean? Each A is equivalent to 1 1/4 gallons of water. Your gallon jug of milk, your gallon jug of spring water in the refrigerator, right? 2A is equivalent to 2.5 gallons of water. And the reason I throw that up there is that is the smallest fire extinguisher that is acceptable for use in construction, according to OSHA. So OSHA says you must have at least a 2A fire extinguisher and at least a 10B fire extinguisher if you have flammable liquids. So that's why we say we want to see a minimum 2A, 10B, C fire extinguisher. But 2A equivalent to 2.5 gallons of water, the question we ask is, how much fire can you put out with a 5-gallon bucket of water? So just something to consider. Each B is equivalent to the square footage of a flammable liquid spill. 10B, 10 square feet, right? That's equivalent to about a 3x3 area. So if you have a flammable liquid spill greater than 3 foot by 3 foot, and it starts on fire, a 10B will not be enough fire extinguisher to put that out. C just means that it can be used on an energized electrical equipment fire. So we want to see A, B, C, because those are the 3 most common exposures that you're going to run into in construction. If you're able to shut off the production of electricity, then your electrical fire just becomes an ordinary Class A fire, and now you can use water on it. Still not a great idea, because how sure are you that that electricity is really shut off? But once the electrical energy is done, it just becomes a regular fire. Responsibilities for the guys at the job site. Monthly inspections need to be done by the crew. Annual inspections need to be done by a qualified inspector. So in this case here, we have a tag from 2016 showing that it was inspected by a qualified inspector in 2016. And on the backside, you can see that monthly, a crew member is inspecting the fire extinguisher to make sure that it's there, make sure that it's in good condition, make sure that it has not been used, right? And we want to make sure that it is available. Also, that it's the right extinguisher and the right size. Where should they be located? They should not be located being used as door chocks, holding doors open, weighting things down. They should pretty much be static, so that where you saw it yesterday is where you can find it today when you have that emergency. And so you will see signs like that fire extinguisher sign pointing down. If the fire extinguisher is not clearly visible because the view is obstructed by other equipment and materials, then a sign should be posted above that fire extinguisher telling you, hey, it's over here. Just come around this, machine, and it'll be right there. These pylons can be placed in strategic locations throughout the floor, and it gives you a good place to put that fire extinguisher. It's highly visible and easily accessible. Fire extinguishers should be placed at each exit and at each stairway. They should be no more than 100 feet away, and if you're doing hot work, they must be immediately accessible. There is no OSHA definition for immediately accessible. We define it like I have a fire. I'm going to turn around and there it is. I grab it and I can get to work. 10 feet away would probably be the max. But there is no specific definition that says your fire extinguisher must be no more than 20 feet away when doing hot work. Once again, here we have that safety board provided by the general contractor, and we have that fire extinguisher there ready to go. As a fireman, I'd like to see 2 or 3 there. But one fire extinguisher can only be used by one person. 2 fire extinguishers can be used by 2 people, or it can give that one person more firefighting capability. And there you have it right there in the door. And just to reemphasize, make sure your emergency response equipment is accessible without lock and key. When you're transporting flammable liquids, solvents, and other materials like that on a vehicle, you must have a fire extinguisher available. In this case here, their fire extinguisher looks like about a 2A, so it's a good size, and it's clamped right there by the seat. So when you get out, open up the back door and it's right there by the back seat in their crew cab pickup, right? That's what it looks like to me anyway. There are a lot of times when I go to do an inspection and I ask a crew where their first aid kit is, and the only person who knows is the foreman, and he says, oh, it's behind the back seat, and or behind the front seat, and then he has to dig through all kinds of stuff to find the first aid kit. That often happens with the fire extinguishers as well. They just tend to get buried and forgotten. It's never a good idea to transport flammable liquids or gases in the same compartment as the occupants of the vehicle, such as in vans. So this is a shot I took of a van that I was at a site, and I actually stuck my head in the window of this van, the passenger window, to talk to the driver, the foreman, and all I got was a cloud of paint thinner. I mean, I think it was caulk and other materials, but I'm sitting there talking to him saying, how can you breathe in here? And he's, what are you talking about? Right? He had become desensitized to it. He didn't even realize how much vapors he was breathing. And I said, listen, it's 2 o'clock. You're going home now, right? He says, yeah, I'm going home. What time did you start driving this vehicle? About 4:30. You're tired, right? It's the end of the day. All right. When you're tired, you get sleepy. When you're driving home in rush hour traffic and you're breathing these fumes, do you think that'll make you more sleepy and maybe contribute to you nodding off and getting into a vehicle accident? So that's one concern with being in the same compartment as these types of chemicals. The other concern, of course, is fire. If there is a fire in this vehicle, you have a very short time to get out without having some kind of injuries. When you're transporting flammable liquids, they need to be transported in the original approved container. They should be protected from damage. They shouldn't just be rolling around in the back of the truck or the back of the van. And the area in which they're being stored should be well ventilated. If you have to use a van like this to transport the liquids to the job site, my recommendation is once you get to the job site, you offload all of those chemicals and you store them in a proper, secure, designated storage area at the job site, rather than dragging them around with you wherever you go. When you have more than 25 gallons of flammable liquids on the job site, they need to be stored properly and protected from exposure to fire, because now we have a significant addition to a fuel load here. So, as before, protected from damage, secured from falling, original container, well-ventilated area. Keep them away from any potential heat sources. And you should probably be using a cabinet similar to this to store those chemicals. This is a fire-resistive cabinet with, I believe, about a 1-hour fire rating, giving fire departments time to show up and extinguish the fire before the interior of this cabinet warms up enough to start affecting the chemicals in there. Any paths to egress, this is very common, by the way, as guys are running around moving their tools and equipment and materials. Somebody gets the bright idea to park something right in front of an exit door, especially one that's marked. In this case here, this is inside a warehouse facility, but you can see a pallet was put right in front of the exit door. Watch out for that on your construction sites. Keep not only the doors and the stairways clear, but the paths to the doors and stairways as well. You should not have to run an obstacle course in order to get out of the building. Have them marked and signed. Maintained free of trip hazards. They should be at least 28 inches in width according to meet in accordance with building codes and fire codes. You should have at least 2 ways to get out. If this exit here is blocked or obstructed or exposed to fire, there should be another way to get out. When you're in that building, every exit door needs to be unlocked or easily openable from the inside so people can get out. Panic bars are a great way to keep a door locked, but still make it so that you can get out in the event of an emergency. If there are no panic hardware and you have to use a doorknob or something to get out, that door needs to be unlocked so that you can get out. So we'll close with just some general fire prevention reminders that apply to every job site. Maintain that general housekeeping. Don't let debris and materials accumulate until it becomes a huge job to mitigate, because the bigger the job gets, the less motivation there are for people to start cleaning up the mess. But the more accumulation of flammable materials you have. Store those flammables safely. Whenever possible, store flammable liquids outside, away from the structure, and bring into the building only what you need for that day or even that period of the day. Make sure that when you're working with those flammable liquids, there's plenty of ventilation. If you have to bring fans in, bring fans in. Be careful bringing in gasoline or internal combustion engine fans, because remember, you might be stirring the air around, but you're also adding the exhaust gas from that small engine into that enclosed area as well. Practice that emergency evacuation plan. Let's see how it works. It may be a terrible plan, and the time to find out is in practice rather than when there's an actual emergency. Make sure you inspect those fire extinguishers monthly, and if you have to use them, or if you find one that's damaged, don't just notify the supervisor. Do that, of course, but don't just do that. Make sure there's a new fire extinguisher to replace it right away. No one fighting a fire has ever complained that they had too many fire extinguishers. All right, but they have complained when they didn't have enough. When you have an opportunity, let's say you have an old fire extinguisher that's about to be repaired, or maybe one that's even slightly damaged, and damage could be something as simple as the labels are no longer legible. Find a well-ventilated area outside and give guys an opportunity to practice pulling that pin and aiming that nozzle, squeezing that handle, and then sweeping in a controlled manner with the goal of placing that powder on the burning material, not on the flames. Right? The burning material is just going to pass through the flames. What puts out the fire is covering the burning material. So train and practice. If you need to, see if the fire department can come out and do some training with you. They love to do that kind of stuff. And that's what tax dollars pay for. Smoke only in designated areas. There used to be a rule that said in areas where there's a fire hazard, you should post a sign that says no smoking. That's a good idea. You should do that anyway. But if you actually designate a single location in which smoking is permissible and tell smokers, here's where you can smoke, you can control that one area much more easily. Ashtrays or butt pans, water available to put out fires. And in our state, in Illinois, that's the law. You can't smoke indoors or near exits. What else? Hot work. Make sure you have that fire extinguisher immediately accessible. Not only that, you have to have a fire watch there for at least 30 minutes after the hot work is completed. And that fire watch person is standing by, making sure that there's no evidence of a delayed ignition of a fire due to slag, due to smoldering materials. Control those exposures. If something is on fire, not only do you want to be putting your fire extinguisher on that fire, but flammable things that are near that fire should be moved away from it so that they don't start as well. If you're doing hot work, make sure you use a hot work permit process. The hot work permit will walk you through the process of eliminating the potential for ignition. If you have to do that by removing flammables, that's one thing. If you can't remove the flammables, then you cover them with a fire-resistant blanket or you wet down the area so that ignition is less likely. Watch out for those temporary heaters, especially those torpedoes. They get pretty hot, and if you have them directed towards something that's flammable over time, you can damage equipment or you can start it on fire as well. And then the heaters too, if they're not tuned right, they can light up on fire as well. No open fires in the winter. Every now and again, you'll see guys huddling around a burn barrel outside, burning off rusted pallets and stuff like that. I don't have any real objection to that. That's probably more of a local ordinance type violation. So look into that. But if you are going to have a burn barrel, make sure that you are only burning natural wood materials. You're not throwing plastics and chemicals into that fire. Wooden pallets are fine, but other materials probably not so much. Have a means of extinguishment immediately accessible, buckets of water, a fire extinguisher, something, and then make sure all flammables are away from that area. Temporary lighting, make sure temporary lighting is strung up properly. That's more of an electrician problem than you guys. But if temporary lighting is not strung up properly, it can contribute to fires as well. Watch those extension cords, take damaged extension cords out of service, have them inspected and repaired by a qualified person, or what's generally easier is just replace the fire extinguisher. Make sure you use heavy-duty industrial rated fire extinguishers that have moisture resistance, and make sure you always use a GFCI when you are running those extension cords and your power tools. All right, so as I said at the beginning, here's that slide again. If you have questions or concerns, our safety helpline number is there. The safety helpline website is there, and we are available to answer any of those questions or give you any guidance that you need. And if you have anything for me, anything that you would like to give me details on, or if I got something wrong, please let me know so I can make this better next time.